Okay, so a couple problems to review for your upcoming quiz on the first couple sections of Module 4. So the first thing we talked about in this module was complex numbers. And remember, the big thing about complex numbers is the square root of -1 was I, and I squared was -1. So if you look at something like this, the square root of -121, well, the negative inside really means this is I times the square root of 121. So the negative inside just becomes I outside. So now you can think, okay, what's the square root of 121? What is 11? If it wasn't nice, you could factor it and break it down. So this is just simply 11I. So 2 is very similar. Square root of -44. Well, the negative inside we know becomes I. So this is I times the square root of 44. So then I can just break down 44. 44 is 4 and 11. 11 is prime. And then 4 is 2 and 2. So I have a group of 2's. So the 2's comes outside the radical. So the 2 is outside the radical, as is the I, with the 11 left inside. So simplifying radicals with the complex numbers like this, very important. So here's some operations on complex numbers. And remember, these really follow the same ideas of polynomials for adding, subtracting, multiplying, and dividing, except for we know that I squared is -1. So when we're adding these, 16 and -12, 16 plus -12 is 4. 4i plus -3i is just simply positive 1i. So those two complex numbers together are just 4 plus 1i, or 4 plus I. So just adding the numbers and the I parts. Okay, if you look at this one, we have the subtraction of two complex numbers. So we have 16 plus 4i plus -12 minus 3i. So we turn the subtraction into addition, and then we will distribute the negative sign. So this becomes 16 plus 4i plus 12 plus 3i. And now you just put those together. So 16 plus 12 is 28. 4i plus 3i is 7i. So again, just change the signs in the second one and add them together. Okay, so the next couple of problems are multiplying complex numbers. So when you multiply complex numbers, we FOIL. So 1 times 2 is 2. 1 times I is positive I. Minus 5i times 2 is minus 10i. Minus 5i squared is the last one. Now, the 5i squared, remember, I squared is -1. So really this can be written as 2 plus I minus 10i. But since the I squared is -1, this is -5 times -1, so this is positive 5. And then I can just add them together. So 2 plus 5 is 7. 1i minus 10i is -9i. Remember, in these problems, you should always get a complex number, something without an I and something with an I. You should never have I squared or I cubed. You should always have, at most, a number and something with an I. So the next one is very similar. It's another kind of FOIL problem. This one I FOIL 6 times 6 is 36. 6 times 2i is positive 12i. Negative 2i times 6 is minus 12i. And negative 2i times 2i is minus 4i squared. Now in this one, you'll notice that the 12i and the negative 12i will cancel. But this last one, I squared, remember I squared is -1. So this is 36, and it's -4 times -1, so it's plus 4. So 36 plus 4 is 40. So that's the stuff with the complex numbers. The other big thing in this chapter we did is we obviously solved quadratics. And we had three ways to do that. We had by factoring, we had by complete the square, and we had by the quadratic formula. So on all these problems, when you're doing a quadratic, and this is a quadratic because of the square, I want to start by getting everything on one side. The only way this is kind of not beneficial is when you complete the square, but if I had to guess, most of us will not be doing this by complete the square. So add 30 to both sides. So now I want to see, can I factor this polynomial? It is a trinomial, no GCF, so we can do it kind of the long way where we do our rectangle, looking for two things that multiply to 1 times 30, which is 30, two things that multiply to 30, but add to negative 11. So those are pretty easy. That's negative 5 and negative 6. Those multiply to positive 30 and add to negative 11. Remember, we got that 30 because it's 30 times 1. So I'll put minus 5x here, minus 6x here. And then I'll just take some GCFs, an x there, negative 6 here, an x for the first row there, and then negative 5, because remember we always take the negative out if the first term is negative, which this one is. So this factors as x minus 5, x minus 6 equals 0. So those are my two factors. So I'll set each of those factors equal to 0. So x minus 5 equals 0, x minus 6 equals 0. So I'll add 5 to both sides, so x will be 5. And if I add 6 here, x will be 6. So 5 and 6 are my two solutions to that quadratic. If it does factor, it is a much, much easier way than using the quadratic formula or complete the square. Okay, let's look at this one. Interesting, it only has two terms, but I do know they're both even, so right away I know I can take a GCF out of 2. So I'm left with x squared minus 9 equals 0. Now if I look at this, you notice this is a difference of squares, because this is x and x and this is 3 and 3. So difference of squares says if they're both squares, this factors as the first one minus the second one and the first one plus the second one. So now we have three factors. 2 equal to 0. Well, 2 never equals 0, so that's not really going to work. X minus 3 equals 0. X plus 3 equals 0. So add 3. So x equals 3. Subtract 3, x equals negative 3. Okay, so the other method, one of the other methods we had in this section was complete the square. Complete the square, remember, always works nice if this first term was 1, which this is. So we start by subtracting c to the other side. This is kind of the one where you do it a little different way. And all these could be done with quadratic formula. This one could not be done by factoring, so we'd have to use either complete the square or quadratic formula. So I move the 9 to the other side. So now I'll take half of this, which is 4. 4 squared, which is 16. So I'll add 16 to both sides. And again, I took the 8, which is the middle term, cut it in half, and squared it. 8 divided by 2 was 4. 4 squared was 16. So on the right side, I just have 7. Now the key thing on this left side, this will now factor as x plus 4, because 4 is what's right here. So if you were to unfoil this, factor it, do your rectangle, you get x plus 4 twice. But I always know it's got to be whatever's in this parenthesis. So I'll take the square root. X plus 4 equals plus or minus the square root of 7. Then I'll simply subtract 4. X equals negative 4 plus or minus the square root of 7. So this is minus 4 plus square root of 7. Minus 4 minus square root of 7. Okay, let's look at another one which would kind of be using this complete the square method. And again, you could always use quadratic formula. So this definitely has the x squared on one side, so I'm going to move the x term over. I could move the 13 over, but I know I'll have to move it right back to the other side, so kind of a wasted step. So we have x squared plus 4x equals 13. So I'll take this middle term, which is 4, and split it in half and square it. So 4 divided by 2 is 2. 2 squared is 4. So I'll add 4 here, and I'll add 4 here. So the left side, we know is going to factor as x plus 2 squared, whatever this is. And that's going to equal 17. So I'll take the square root of both sides. So this is x plus 2 equals plus or minus the square root of 17. So I'll subtract 2. So x equals negative 2 plus or minus the square root of 17. So our two solutions, negative 2 plus square root of 17 and negative 2 minus square root of 17. Okay, so last section the last method we had to do these were by the quadratic formula. Quadratic formula is by far the easiest one, where you just get everything on one side, and you can identify what your a, b, and c are. So in this case, a is 2, b is negative 3, and c is negative 4. So if you recall what the quadratic formula is, negative b plus or minus square root b squared minus 4ac all over 2a. So negative negative 3 is 3, plus or minus the square root, negative 3 squared minus 4 times 2 times negative 4 all over 2 times 2. So now if we work out what that discriminant is, so that's 9 there, negative 4 times 2 is negative 8. Negative 8 times negative 4 is positive 32. So 9 plus 32 is 41 over 4. Now we get kind of lucky in this case because 41 does not break down. There are no perfect factors that multiply to 41. So our two solutions are just 3 plus the square root of 41 over 4, 3 minus the square root of 41 over 4. Okay, last one. So again, not everything on the same side, so I'm just going to add the x squared because that seems to be the easiest. So that'll leave me x squared minus 4x plus 13 equals 0. So in this case, a is going to be 1, b is going to be negative 4, c is going to be 13. So x equals negative negative 4 plus or minus the square root, negative 4 squared minus 4 times a times c, all over 2 times 1 over 2a. So this is 4 plus or minus, so my discriminant, again, you can put this in the calculator. 4 squared is 16. This is negative 4 times 13, which is negative 52. So then we'll just take 16 minus 52, and that gives us negative 36 over 2. Well, if we think about square root of 36, well, there's definitely an I there because of the negative, but then it's just square root of 36, so it's just 6i, or I times 6 over 2. And now we look at these values here, and they all can divide by 2, so I'll just divide them all by 2. So 2 plus or minus 3i. It would be over 1, but you really don't need to put that part. You can just leave it as 2 plus or minus 3i. So, that's your review for the quiz. I wish you luck.